Hello, everyone, and welcome. Thank you for joining us today for our fireside chat Beyond the Waitlist, a data driven guide to AI infrastructure economics. We're really excited to have such a strong group of AI leaders, operators, and builders with us today. As GPU demand continues to surge, many teams are finding themselves stuck on waitlists, locked into expensive infrastructure, or making critical decisions without clear visibility into performance or ROI. Today's session is about moving past the noise and grounding AI infrastructure decisions in real data and real economics. Before we begin, just a couple of quick housekeeping notes. This session is being recorded and the replay will be shared all to the registrants after the event. Feel free to drop your questions in the chat or Q&A at any point and we'll address as many as we can during the conversation. Well, today's conversation features Carmen Lee, CEO of Compute Exchange and Silicon Data. Carmen leads two pioneer organizations at the forefront of AI infrastructure evolution. Together, they form a unified ecosystem bringing liquidity, accountability, and trust to the global AI infrastructure economy, with a bold vision to establish compute as a transparent, tradable financial asset class. Guiding also today's fireside chat is Hao Lin of Cytex AI, who brings a data driven perspective at the intersection of AI systems, infrastructure economics, and real world deployment. Hao will be leading the conversation, digging into data, benchmarks, and economic realities shaping AI infrastructure today and translating technical complexity into practical insights for builders, operators, and investors alike. With that, I'll hand it over to Hao to kick things off.
Thank you, Sheila. It's great to be here with everybody and Carmen. Hi, everyone. Welcome to the inaugural episode of the webinar series. It's called the AI Fabric. My name is Hao Lin from Cytex. Just one sentence, we're a next-gen provider of intelligent computing infrastructure for AI. Sometimes we're also known as a neocloud. Today, I have the pleasure to be joined by a friend and the CEO of Silicon Data and Compute Exchange, Carmen Lee. I met Carmen back when she was at Citi. We kept in touch when she ran global data partnerships at Bloomberg. And now she's the founder and CEO of Silicon Data, as well as the CEO for Compute Exchange. This really puts her in a unique position to offer some great insights on AI infrastructure economics for the audience today. Hi, Carmen.
Hi, Hal. This is great. I'm glad to be your first guest. This is awesome. Such an honor.
Great. You and I just this week chatted about the recent volatilities of AI compute market. Let's get into the market reality check. So, Carmen, the list price for H100s on major hyperscalers often sit around or above $4 an hour. So based on your global transaction data, Silicon Data, what is the actual real price in the US spot market right now? And why do specialized AI clouds see a completely different spread?
This is a great question, Hal. I'm gonna share some data points here. So obviously, we are a data provider. We don't control how everybody price their GPU clusters. What we can share is our observation. So what you see right now is our portal. If you're a client, you will see the data every day. Right now, I'm selecting the H200. I know we mentioned H100 global average. So you see the neoclouds is trading at $2.40 for on-demand aggregate. Obviously we have over 50 different data sources. The hyperscaler is trading about 3.5x than neoclouds. And this is not a outlier. If we go to our indices, so we publish H100, A100, B200 indices live every day on Bloomberg and Refinitiv terminals. You see that price every day where the H100, your question is today is 2.31 cents globally for neoclouds. The hyperscaler is trading at 3.35 per GPU per hour. we normalize the unit, right? So this is very interesting. This is actually a pretty consistent story. It doesn't happen just today. Happens in the past, I believe, 2.5 years since we've been tracking them. You see the price here. Both the blue lines are the H100 indices. The lighter blue line on top is the hyperscaler H100 on demand per GPU per hour. And the lower bottom blue is the NeoClouds H100 per GPU per hour. They're pretty consistently about three to 4x, right? Differences. And the A100 tell a similar story. The brown line on top is the A100 hyperscaler indices. The brown line below is A100 NeoCloud on demand prices. So it's, and then the B200 is here. We don't have enough data points for hyperscaler B200 indices, but a lot of those information are available to you at Bloomberg Refinitiv. So it's really interesting how, right? Like people just assume, hey, I'm paying, some people may not realize that they're paying 3x, right? At hyperscaler versus NeoCloud, we have clients who are savvy enough to know, oh, I'm paying more, but how much more, right? Usually it depends on the chips. A100 premium is less than H100. The GBs and Bs, we need more data to tell the whole story, but the price difference is real. So another thing I think is interesting to point out, obviously everything we do as Silicon data is reflecting the price today, right? Yesterday in the historical data sets, we don't predict because we don't have data to tell you what's going to happen tomorrow. What's interesting is we launched with Polymarket um, early this week, whatever you call that, prediction market for the H100 specifically. The question is GPU NeoCloud rental prices will hit what price in February, right? So February 28th is a settlement day. And again, we'll settle against H100 indices that published by Silicon Data. You can get from our website as well. What's interesting is, again, you see majority of people think it's been trading around 2.35, right? Another prediction market is April 30th. And then people seem to think that, oh, it's changed right, real time. 2.40, right? That's higher than today, right? So tell you how the industry thinks, right? Again, this is NeoCloud only. So I think this is interesting, give you some context of what people think going forward. Again, we're not providing any guidance, but I love to share what happened in the past and what we, how we sort of bring the transparency forward. If you ask my opinion, why do I think there's huge price differences? I guess, it's market power, right? A lot come down to, even though you might know you're paying higher prices at hyperscalers, doesn't mean that, it's easy for you to swap out or move to neo cloud. What we have seen a lot recently, how is there are clients with hyperscalers, but as they deploy a lot more AI use cases, they're always exploring neo cloud partnerships versus just relying on hyperscaler solely, right? I think that's a really good trend for everybody.
That's a really refreshing take, Carmen, with data. You don't see that very often. Obviously, there's a market sentiment, but that's great insight. And we often also hear about the GPU shortage, right? You've argued that there's a deeper efficiency crisis. So how does a hyperscaler tax, which is layers of virtualization and general purpose plumbing, physically degrade a tensor operation?
There's definitely a premium they charge, right? And it also depends on your spot on with shortage, right? We, just so everyone knows, Cytic is a great partner for us at Compute Exchange. Compute Exchange is a marketplaces for GPU procurement process for all the for NeoClouds and also our startup ecosystems. So we have a lot of like good deal going on for A100 to H100 to B200 to AMD other chips, right? So we definitely observe a lot of demand, at least through compute exchange platforms. And it's not the easiest thing to source GPUs at the terms, at the price that people, like to have. So the shortage, I think it's really true. I think the prediction market give you a little sense of the prices. If you look at indices, the H100 price did go up about 15% for the past weeks. So people always assume, right? We get a question all the time, shouldn't the price got cheaper, right? Every month, right? As the chip gets older. It's actually not true, right? It's all supply demand driven. Even it's older chips doesn't mean that the price always will go down. It really depends on, your chips quality, the performances, where it's at, and what's really people need it for. And then to your point about the price premium by cloud, we use hyperscaler as well, and we use a lot of neo cloud. For us is what makes sense, right? Obviously, sometimes if you locked in to a very long contract, do you want to do so, right? Or you want to do something a lot more flexible, but given, on-demand prices, they do come with volatility. You see the volatility here. It's about 114 for the H100. That's meaning if the price will jump up and down on demand a lot, right? Would that work for your business model, right? Your margin can be from 20% margin to 80 to negative potentially, depends how much GPU you use. Is it something your business model can tolerate, right? It's all become a CFO, CTO sort of a team effort to manage this cost.
Got it. Well, uh, but you recently also talked about, there's up to 37% performance variance between, H100, same GPUs across different providers. So, for a startup, if you're a startup founder, it's really, I mean, it's probably not a great analogy, but like buying a Ferrari, getting a lawnmower engine, right? So, what are the primary hidden killers of performance? Is it hypervisor? Is it networking interconnect or something else?
It's a great question. I wish can be that straightforward. Can you see my screen? Just want to make sure you can see my screen.
Yes.
I think you're talking about this paper. So we published this GPU third-party research paper at GPU conferences. It's also well distributed with the ecosystem. So this is how we do it. The way it's very similar how do you look at it, right? You would like to think if you pay a premium in terms of pricing, you should get better service, get better products. It's only logical, right? You don't have to get 3x better, but you should get better. Is that true, right? So our analysis, unfortunately, tell a different story. It may not be true, depends on your use cases, right? So what's interesting about our research is the question we're asking is pretty much the same, right? Is A100, H100 same across different providers between neocloud hyperscalers? Does price really reflect the quality? You have same GPU, does the performance matter, or is it pure lottery system, right? So we did a lot of research on that. So we're talking about a third-party benchmark called Silicon Mark, which what we do is we really demonstrate GPU performance's variability in conjunction with our rental price dynamic. So hopefully we'll give you the whole picture from pricing to performances by itself. So the test we run across 11 cloud providers, including hyperscalers and neoclouds, we ran over 3.5 thousand physical GPUs, and over 6,000 benchmark has been performed for the past 4 months. We track the UIDs for every GPU, so we make sure every GPU measured multiple times, and it's consistent through different test results. And then we did prove that it's pretty consistent with result output. So it's really interesting. So we try to separate three variations. So execution level, so same GPU, same machine, repeat runs. So that's we take out that kind of variables. Second, the intra-provider variation. So same GPU, same cloud, different physical unit, right? So it's really about the neo cloud or hyperscaler themselves. And the third is inter-provider variation. So same GPU, different cloud providers, right? So how can we compare them against each other? So the baseline is the same GPU on the same machine, repeat runs measured. There's a pretty minimal variation. So typically less than 9%. So basically you can, we test noise, cloud jitter, short-term thermal effects. So the benchmark itself is very stable and reliable. That's one thing. And I encourage everybody to test, to be honest. You can go to Silicon Mark, Silicon Data website, and it's completely free. You don't have to register. You can run tests yourself on your graphic cards even, and then just to have fun, right? Based on what we see, is the intra-provider variation, it's real, right? So really based on the manufacturing differences, there's no chips that are molecularly level identical with each other, which I think everyone understands. And the power voltage can be very different. The scale variation can be different between 10 to 30% within the same provider for identical GPU models, right? So think about that. So within the same provider, that can be very different. Again, this is not provider issue. It's really about like TSMC, the fab, and the issues around that. The second thing is interesting is, and we're talking about here, is the inter-provider variation. It's also a huge differentiator. It's about 38 variation maximum we observed across hyperscale and neo clouds, right? So meaning you're paying $1, right? The same GPU, you actually get very different performances. And then the transparency is low. You might not know, you're not getting what you pay for. So the interesting thing we see is the power limits, cooling systems, PCIe, software configuration. So there's a lot to do than just GPU. It's really the server level, the machine level differences really drive the performance difference. And again, so we love to delve into details. I know we have very limited time, so happy to share the paper with the audiences here and just reach out to the organizers, and I'm sure they can distribute the paper to you.
Oh, sorry. Go ahead.
No, go ahead.
No, I was going to say that's really interesting. I was actually, a percent short, right? 38% variation. So now we've established that, there is a variation in price. Inventory is volatile, and then there's a variation in performance. So let's dig deeper into the performance aspect. And I think you guys have some benchmarks. Um, you know, Silicon Data ran head-to-head benchmarks comparing, Cytics and hyperscalers. From an economics perspective, why is a cheaper hourly rate on a big cloud often a trap for training runs?
It's a good question. And by the way, all the tests we have done, including the Cytics test, is completely unpaid. So we literally just run tests ourselves. And I encourage people to run so too. If you are Cytic clients or anyone, you can just run tests yourself to sort of figure it out too. Everything is repeatable. You can repeat the test yourself. So what's interesting is, let me jump into the Cytic report we have done, right? That's the B200 reports we did with Cytics. So we run over 2,800 benchmarks across providers for this particular Cytics against neocloud and hyperscaler. Hyperscaler is not included, but in the previous study we did. What's interesting is with Cytics specific clusters we've been tested, we test about I believe 24,000 different benchmark tests. The results are really interesting, right? If you look at, we'll go to get to details later. If you look at pure flops, Cytics actually perform at a medium and slightly below the medium compared to the neocloud providers. And if you just stop there, you will think, oh, Cytics is not the best. That's actually not the best, not the best conclusion you can draw because we did a bunch of real world performance tests. So we'll look at number of tokens you can generate it compared to the neoclouds. Cytics is actually 16, 17% better than neoclouds, even though the raw flop is at a medium or slightly below the medium. So which is interesting, right? Not only Cytics have better throughput, tokens per second system-wide, also have better step time differences than other neoclouds, meaning you're faster and you produce more token. We can dive into details later, but this is a really interesting outcome, right? So you do have to test everything, not just the machine itself performances, also LM token, depends on use cases. So we did is time to first token. Cytics is about 36 milliseconds and neocloud is about 42. So it's 15% lower in terms of latency. The concurrency for the hundreds, I think, is about 7,000 tokens per second. NeoCloud is about 5,000 tokens per second. Again, depends on use cases. The 37% performance advantage may be meaningful for your workflow, right? So this is really interesting. So another thing we want to talk about is, hey, the raw flop, how do we think about raw flop number? How do we think about system bottlenecks? How do we think about the performances at the end you're getting as a customer, right? So we keep emphasizing that GPU, even though the GPU is maybe fast individually in isolation, but as a machine, how do you stitch things up together actually matters, right? Your memory, your cooling, your interconnect, everything actually comes to play. So this is a really interesting report. Another thing I would encourage people to think through, because we run so many tests across different providers, is consistency, right? People usually want to optimize for whatever they want to optimize. If you see any benchmark run by the different parties reporting by themselves, obviously they optimize for their own use cases, which is fair. For us is we want to make sure things are comparable across our different providers. So we don't optimize for anyone, right? It's a standardized apple to apple comparison. So what's important is consistency, right? You might be optimized all the way to 100%, but doesn't mean you will always get that number. So what we do is we run consistent numbers, and then we also take a look at the variance. So here you see Cytic's characteristics. So it's better, absolutely, than a medium number. It's also have a lot tighter performance distribution. That's very important, right? It's meaning the performance is a lot more predictable than some other neo clouds, which may be better, but then have a much wider variance. And then for the any end users, you may experience, some sort of volatility while you're running your workloads. That's something I think I want to highlight. I don't know if you have follow-up question on the report. We have, but things I do want to talk about is we see a lot of clients now getting more sophisticated, right? So before, and then we experienced this how, right? Before they say, hey, we're gonna commit with this neo cloud providers at this price, they start asking questions. Have you been tested? Have you been verified? What's the performance look like? Are we sure that's what will be getting as end customers? Right? People got a lot more educated and more aware of the price variance across different new cloud providers. So I give kudos to House team. They are very proactive, getting this audit done and then get configuration and analyzed. And we talk about how can we make them better? How can themselves make get it better? I think those are very important next steps for any new cloud providers. So yeah, any other questions, Hal?
I mean, that's a great insight. I remember you guys spent I think 4 or 5 days running the test, kind of in the black boxes. We didn't know what you were doing, but that's a lot of tests that you guys ran, just with us. So, great data.
Yeah,
Also,
one thing
Cytics, yeah, go
yeah.
ahead.
I do have one quick question from the Silicon Mark team to you is obviously what we see is the end results, right? So we are impressed by your token outputs. We're impressed by your latency, right? Obviously we know where the machine is stationed at geolocation wise. The question from Silicon Mark team to you is, what's your thought process from product point of view? Is a particular reason why you optimize for token inferencing use cases? What's your thought process on neoclouds in general?
That's obviously could be a deeply technical conversation. But I think one thing I want to point to is sort of the upbringing, right, of Cytics. So, every neo cloud and cloud provider, sort of has a, how they started, and a lot of companies started, with different backgrounds. Cytix started uh, by serving a couple really large financial services customers, that need a lot of computation power. So from day one, we were architected to run large cluster in parallel, having to run them, consistently, right? So it's not a project-based thing. They keep going. And then lastly, the environment, right? The data center, the gear, the people that manage them, the security practices, all have to um, satisfy the requirements of these financial services customers, right? So as a result, we're very, very good at running, 1,000 or 10,000 node clusters, as good as we can run a 10 node cluster, right? And I think that's really what makes us a little different. I don't want to say good or bad, but different. And I think that's one of the primary reasons, that got us to the result, and sort of the answer to your question. I'm sure there are other technical things that I haven't gotten into, but I think that's one thing that kind of sets us apart.
Very cool, very cool.
So,
Yeah, another thing I encourage people to start to cut you off to think through your use cases, right? If your use case is small,
mhm.
latency matters to you, output must matters to you versus let's say scientific research, right? You probably care more about flop 64 output, right? Raw output. I would think that'd be different use cases. And then you should benchmark, look at different benchmark numbers, compare them across neocloud and hyperscalers, right? It's another thing I would say. It's not one
Got it.
metric all right.
Very good. So, we often encourage teams to, stop renting the VM and start buying, time to market, right? So Carmen, when you audit startup balance sheets, how much runway is typically wasted on inefficient compute cycles?
A lot. I think sometimes it's twofold, right? You're wasting money, obviously, Number two, you're wasting people's time, which you can argue is more precious, right? You look at people who ever config, deploy workflows, and doing those procurement decisions. It's not like a regular procurement person, right? It's actually AI engineers, the CTOs. And that time is valuable, right? If you imagine you have to manually compare specs across 50 neo cloud providers and verify the performances, is it optimized? Where is it at? It can sunk into weeks, right? And those are times you can actually working on your models, your products better. And then at the end, you might not choose the the most optimal results. And again, you
Right.
run into a performance issue. So the money per GPU per hour dollar you pay is one obvious in your face number, the cost, right? Another is the time sunk and then the inefficiency, right? So I highly encourage people to really think through how can you get better going forward as you everybody spend more money, more time, we like it now on GPU procurement and performance testing.
Well, then, with that being the case, how does a purpose-built infrastructure for high concurrency training, like what we have in some of the neoclouds, how do they solve the ROI gap that general purpose clouds ignore?
I think just really number one, testing, right? Look at testing results by third party and then really start digging through, asking the questions before you say, hey, you charge me $1.50. Amazing. It's the cheapest and I will go with you. It's not homogeneous as we demonstrated, up to 38% differences, right? So
Yep,
definitely ask the question, show us the results, tell us how you test it. Let me test it as a customer, right? To verify that. And ask all the questions that Cyclics is doing, right? Can they demonstrate by third party benchmark, hey, they perform at this level, right? So all those things are worth asking before you deploy a large workflow, and then just rely on cost itself as an
got
indicator
it.
of quality.
Got it. Okay. Well, let's segue into a lightning round technical questions. So currently Cytix is betting big on the B 200, 300, and FP4 position. So when you model the cost per token, so that's really what Blackwell versus Hopper. How does the data justify paying premium for newer hardware today, or is H100 still the value play?
Again, depends what we're looking to do. We were looking at the performances for the B200, the differences. So what's interesting, I think, is if you this is the wrong slide. But if you're looking at the B200, for the right use cases, it's definitely worth it. However, it's not a guaranteed you get B200, you get all the guarantee results you're supposed to get. It's really about, okay, is your software, is your system actually can leverage its capabilities. So the hardware potential, obviously, for the B200 is better than H100 by any comparisons. Real flops, memory bandwidth, power, you need more power for obvious reasons, right? But the important thing is you can't really realize all the price premium you pay unless you have the performance, the software layer, the topology layer to really realize that. So this is what we see here, right? The Blackwell reality check. Make sure you test and make sure you can leverage and then make sure you can get your efficiency crisis narrative right.
Got it. Well, your background really, you specialize in risk management. At what point should a Series A, Series B startup, stop renting on demand and commit to a reserve, neo cloud contract, right? Where's the line where building your own data center becomes a capex suicide sometimes?
I don't think people are building, unless to your point, like financial services is a little different, right? For whatever reason, a lot of different reasons, they need their own data centers. That's fine, right? Regulatory requirement. But what we see as we serve a lot of customers, sometimes with you, right? You see, sometimes they know, hey, I need this amount of GPU internally for my researchers, for our product development. That you can probably forecast, right? You understand how much we need. Those are probably better go reserved, right? So you know you need how much, and then in reserve usually give you the guarantee of pricing, and availability, right? If for customer use cases, so that's a good problem to have. Sometimes you scale faster than you thought you would be, right? Then you have to switch your own demand because you're not getting enough reserve GPU allocation. Another thing is paying more attention to the market dynamics, right? So sometimes you just assume, hey, the price always go down, right? Hey, if I do 12 months reserve, it's always going to be cheaper than monthly. If everything's equal, that's probably the case, but sometimes supply and demand can shift. one day you're paying one prices month to month, the second day the price might shoot up because supply and demand. So I really caution people on how you really think through the risk management of GPU resources. Another thing is be careful, what depends on use cases. Sometimes the client use cases may require different asks from data centers, right? You might need some SOC 2 compliance versus sandboxing environment for your own testing. You might not need that. So verify that beforehand, right? Before you procure GPU, maybe need it because it takes a while to get SOC 2 compliance, especially for data centers. And also the latest and greatest chips, right? Everybody want the latest and greatest. People talk about Vera Rubins nowadays, right? It's not live yet. But again, what's guaranteed in the machine physical physics level, right? You're supposed to get a lot more flops. You're supposed to get a much bigger terabyte of memory bandwidth. It's all true, but how are you sure you need that? And even you need that, that doesn't translate to you can realize that. Depends on again the system, machine, software configuration through your leverage capability. So again, make sure you know the timing, test verified, and then really be flexible with reserve versus on demand. For procurement, you will build your own data center, that different story, then depends on business model. You want to keep for yourself, or versus you want to make sure you can rent it out to other customers, become an inferencing provider, different business model, different ROI, versus your cost of capital, how much you're gonna finance it for, and then are you getting a discount on those secondary wholesaler machine? Can you back to benchmark? Can you verify if you buy secondary, like secondhand machines, the performances before you commit, right, to build up a brand new data center? So those are all interesting questions. And depreciation curve is another story, right? How do you
Yes.
residual, the residual value, especially you're paying a certain interest rate, your financiers may be very keen to understand your residual value of the machines they help you finance, right?
Got it. Okay. So let's kind of go to the future a little bit. Let's look forward. You know, if we look at the future market for GPU capacity late this year, late 2026, what is the one trend that nobody's pricing in yet? Is it power? Is it liquid cooling? Is it, shift in model architectures?
I wish I know. I wish I can tell the future. I'm pretty excited with a lot more GPU resources will coming online, right? I'm very excited for March, very excited for May, very excited for end of this year. Just because more supplies are coming online doesn't translate to or become a buyer's market, right? We may have a lot of buyer coming in, outpaced how much we can bring things online. No, I don't think I know. Maybe some other people have a opinion on this, right? I don't know how the supply demand curve will keep shifting, right? But I do agree with you. Any of those things you mentioned can be a bottleneck. Oh, at least price driver. Like we talk about CPU shortages, RAM shortages, right? In the past months, and then maybe going forward a little bit. It's always different bottlenecks at different times, for better or worse, right? Before I remember last year was like packaging was the issue. And if you're looking at different geolocation, for example, North America, clearly we have energy issue. But in China, they may have chips issue. In Europe, they have enough energy. They might have a connectivity issue or other issues, right? So bottlenecks are different based on the geolocation, right? So it's a ever evolving dynamic market for better or worse.
Yeah. Well, last question for you. For the team currently sitting on a wait list, 3 or 6 months, what is the first thing they should audit in their current infrastructure to stop losing money?
Number one, just look at number who you have, who is running what is the performances, what is the bottleneck. You think you're getting this? Are you really getting the kind of performance you're looking for? Right? If you have time, do a deep audit. Shouldn't take you too much time because a lot of machine, a lot of things should be automatically run. For example, our quick mark benchmark taking 90 seconds, right? It should be can be pretty efficient. You leverage the right tools, open source tools. Again, ours are free, right? So make sure you do a quick audit and I really understand. I know it's very hard to project the future. Understand what's going on in the market, and then start reserve compute early on. It's a lot of my clients. I don't know about you, how they want GPU yesterday,
Mhm.
right? So we try to tell them to do, be like, can we help you forecast what you need, let's say in April or May? We can help you get GPU reserve way ahead of time So we do see customers a lot more um, sort of plan ahead now. There are people reserve GPUs from us in November. I mean, this coming, which is like what, 8, 9 months away, right? They just want to make sure they lock in the resources as no one really knows what's going to happen, right? Lock in the resources at price is reasonable from today's point of view. That's all you can really do, right? And then make sure you have some flexibility while you plan ahead. So I encourage people to do so.
Fantastic. Carmen, so I think, really the theme, and, based on your answers today, is that, really understand, what you're trying to do and what the use case is. And then, test, so test with providers. You can test with Cytix today, see how the performance, is for your use case versus the cost, right? And then, if anything else fails, you can also, consult Silicon Data and Silicon Mark, for some of the benchmarks that they have and some of the best practices that they may provide. So, Carmen, it's been a delight. Thanks so much for jumping on with these profound insights. This concludes the fireside chat portion of the inaugural episode of the AI Fabric series. Please stay tuned for our upcoming episodes by following us on LinkedIn. Back to you, Sheila.
I
Well,
see you have some questions on the
yeah.
Q&A channel. That's great.
Yes. Well, thank you so much, Hao and Carmen. Now we have actually very interesting questions from our live audience. Well, don't worry. For those questions who will be catered today, our team will follow up after our session. Well, one very interesting question, Carmen. He's actually a chief information officer. So if Cytex has 37% better overall throughput for tokens, how does that translate to cost? What is the cost differential?
That's a whole question. I don't know about your cost and your pricing.
Well,
Yeah, well, how is this?
thanks for that question. Whoever that asked the question. So, I think going back to what Carmen was referring to earlier in, her benchmark test, right? It's really about price performance. It's not just price or just performance. So, if you have an X number of tokens per, token unit, for Cytix, and then you have Y, on another provider, then you got to look at that versus the cost, the dollar per hour on GPU, right? And that's when you can arrive at a conclusion. Okay, this provider might be the most, cost performant for my use case. Going back to the approach that Carmen has suggested throughout this interview. So take a look at your use case. Are you doing tokens? Are you doing training? You care about flops. Really highlight what's most important to you, and then do that versus the cost, dollar per hour per provider, and then you'll find out what is the best deal for you. Sheila?
Right? Well, that's very insightful. How? Well, additional question from again from one of our attendees. Are you planning to compare NVIDIA chips H100 and B200 and the Google TPU Tensor chips?
We want to compare everything. We're agnostic of prices. It's all based on if we can get the data, right? So for TPUs, we only get device data at this point. And then I don't think it's comparable with data center quality chips, right? But it's our goal to do so. And then if we do AMD, right? We do MI300. You can see the rental prices here, the market prices. So that's the wholesale refurbished prices. So, and then we do benchmark AMD performances as well. It's not in the report here because we are very, for better or worse, we do NVIDIA chips, make them apple to apple, but AMD is definitely in our database, both rental, retail, as well as benchmarks.
Well, thank you so much, Carmen. Well, as much as we'd love to cater any more questions, I guess before we wrap up, do you need to say anything else? How any message for our live audience or attendees for today?
No, I just want to, say thank you for joining. Like I said, this is the first episode of many. So on the right-hand side, you see the QR code for our LinkedIn page, and on the left-hand side, you see Silicon Data's. Please follow us on LinkedIn, and we will announce more of these episodes in the series. And again, I thank you for attending, and I think Carmen and I both will welcome the opportunity to chat if you have interest. Thank you very much.
Well, thank you so much, everyone who joined us today. We hope this session helped to reframe how you think about AI infrastructure, not just a capacity constraint, but as an economic system that can be measured, optimized, and strategically managed. If you were able to stay for the full session, or if you'd like to revisit any part of our conversation, the webinar replay will be sent directly to your inbox. The conversation around AI infrastructure economics is only just the beginning, as How mentioned. Don't stay on the AI waitlist. Thanks again, and we hope to see you at the future event.
Have a good
Thank
Thursday.
you.
Bye.
Bye bye.